have to predict what will be his weight. Okay. So height is given and you have to predict the weight of the person. So here in the training, how many examples we have considered? One. Already in the training, we have considered several examples. Okay. So the first example is like this. His height is h1. His height is h1 and his weight is w1. Similarly, for the second person, his height is h2. His height is h2 and the corresponding weight is like this. This is the weight. This is the corresponding weight of that person, which is W2. There is something wrong with the writing pad. Please bear with me. So like that, if you consider ith person, for ith person, this is the height. This is the height. And the corresponding weight is this one, yi. Okay. So the here the target variable is weight. The target variable is weight. And the independent variable or the input variable is height. So given the height, you have to predict the weight. Okay. If you look at ith persons, okay, this line which is shown in the red color, this line which is shown in the red color, this is called regression line. This is called regression line. So how it is defined? How the regression line is defined? You all know in perceptron learning algorithm, we all know the, sorry for this, yi cap. This one, you all know that predicted value of the weight y cap is equal to some intercept b naught. మనం b naught కాదండి, మనము చెప్పుకునేటప్పుడు we have taken coefficients as parameters as w naught. Okay, y cap is equal to w naught plus w1 into x. Okay, so here the value to be predicted is weight and the input is the height of a person. Okay, and our regression algorithm has come up with a what do you call hypothesis, okay, which says that the predicted weight is equal to some w naught plus w1 into x height. Okay. Okay, if you look at this for ith person, if you look at this diagram, so the blue dot represents observed value of yi. అంటే it is the actual weight of ith person. But your algorithm predicted his weight as yi cap. So the predicted value is different from the observed value. Okay, here the predicted value is less than the actual value or actual weight of the person. So how do you define error? So look at this equation. How do you define error? Error for the ith sample is equal to the observed value or the actual value for the ith person minus the predicted value for the ith person. Okay. So this is what is known as random error. Random error for observation I or for example I. Similarly, here we have considered how many examples? How many examples we have considered here? You tell me how many examples we have considered here? Any one of you? How many examples we have considered? In all, how many examples we have considered for training purpose or to find out this regression line? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in all 15 examples we have considered in the training set, okay, to come up with this regression line whose equation is given by this y cap is equal to w naught plus w1 into x. Okay. So if you know how to calculate the error, now what will be the error for all the 13 examples, for all the observations? This is the error for ith observation. What is the error for the first observation or first example? What is the error for the first example? So for the first example, the error is this much. This is the error. Okay. Uh, his actual weight is greater than the predicted weight. How do you know the predicted weight for the first case? What is the predicted weight for the first case? For the first example? For the first example, the predicted weight is this. Okay, whereas the actual weight is this. So the difference between error for the first example E1 is equal to the actual weight. So this is the actual weight and this is the predicted weight. So this difference is nothing but E1 error for the first example. Similarly, calculate the error for all the examples. So what is the total error? How do you calculate the total error? Total error. Let us assume TE represents the total error. So how do you calculate the total error? For each example, I is equal to 1 to n. For I is equal to 1 to n. చెప్పండి EI. Okay. So in our case, how many examples are there in the training set? There are 15 examples. Antena? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 15 examples. So in our case, this is sigma I is equal to 1 to 15. And how do you define error? How do you define error? Actual value yi minus the predicted value for the ith. Predicted value is shown mathematically as yi cap. So for all the 15 examples, we calculate the error and add all those things, we get total error. Of course, if you divide this with 15, we get, if you divide all the error by total number of examples, we get average error. Average error. Most of the times we use the error for a particular example, we use this term. The error for a particular example is called loss. ఒక particular case ki the difference between actual and the predicted value is called loss. And if you calculate the mean error for all the cases or for all the observations, it is called cost. So remember this difference, it is given in the theory as well. So if you look at this, the loss, the term loss is used when you refer to the error for a single data point. Okay. Whereas if you calculate the error, the average or total error for all the data points, it is called cost function. So I hope you understood the difference between loss function and cost function. Okay. Sometimes this loss is also known as empirical risk. Another name for the loss is empirical risk. Okay. There are several ways. We have shown only one way of calculating the error. There are several ways in which you calculate the loss. I mean, there are several mathematical expressions to calculate the loss. Okay. And the factors that affect the method you choose for loss calculation are what kind of learning algorithm you are using. This is one factor. అంటే లాస్ ఫంక్షన్ క్యాలిక్యులేషన్, లాస్ వాల్యూ క్యాలిక్యులేట్ చేయడానికి ఏ ఫంక్షన్ వాడతాము అనేది ఇట్ డిపెండ్స్ అపాన్ ఫస్ట్ ఫ్యాక్టర్, the type of machine learning algorithm you have chosen. Okay. And whether the expression can be differentiated or not. You know, we use differentiation to calculate the slope. Okay. So we need to calculate the slope. So I will explain why you need to calculate the slope of the error function. So this is the second factor, whether the function that we have chosen can be differentiable or not. Okay. In other words, can we is a derivative exist for that function or not? That is the second factor. And the third factor which influence the selection of loss function is what percentage of data are outliers. Okay. Outlier in the sense extreme values. Okay. Good. Outlier in the sense extreme values. For example, if you take your class Okay, there may be few students whose performance is very good in academics. There may be few students whose performance is very poor in academics. They are extreme values. They are known as outliers. Okay. Rest of the students, they are normal, average. We say they are average students. So those whose performance is exceptionally good or exceptionally poor, they are known as outliers, extreme values. Okay. So these are the three factors that influence the selection of a loss function. Because we considered regression, the losses that we calculate, they are called regression losses. Okay. If you consider another learning algorithm, suppose if I consider what do you call classification, I have to calculate the classification losses. Okay. Let us take a dummy data set to calculate various types of losses. Okay. So in our case, how many examples we have taken? We have taken how many examples? First, second, third, fourth. Four examples we have considered. For the first example, the observed value or the actual value is 100. Okay. Here we have taken two models. This is first model. Okay. And these are the values corresponding to the first model. And these two columns corresponds to the second model. Okay. So for the first model, the predicted value is 101. Predicted value is 101. So what is the actual value? 100. And what is the predicted value? 101. Because the predicted value is a numerical quantity. This is the example of a regression. Okay. So what is the error in the case? In our case, actual minus predicted. So 100 minus 101. The error is minus 1 for the first example. So this is what is known as E1. Error for the second example, E2 is equal to actual 200 minus 199. This is one. Similarly, for the third example, minus 1 and the last plus 1. Okay. So if you calculate the average error, in this case, average error for the first model. So average error for the first model. So average error for the first model is equal to, so what is the total error? This is for the first model. Total error, if you sum all the errors, it is 0 divided by how many examples we have considered? So the average error is 0. Okay. For the second model, means you have used two learning algorithms to solve the same problem. The first learning algorithm has predicted like this. These are the values predicted by the first learning algorithm, and these are the values predicted by the second learning algorithm. Okay. So the actual value is 100 and the predicted value is 110 in case of second model. So this is with regard to second model. So what is the difference between actual and predicted? Minus 10. Similarly, for other examples, you calculate the predicted. And if you calculate the average error for the second model. Okay, so sum of all the errors, suppose this is E1, E2, E3, error for the third example, error for the fourth example. Sum of all the errors, so sigma I is equal to 1 to 4 in our case, EI divided by 4. So which is 0. So according to the cost function average error, according to the cost function average error, we say that both the models performance is same, because because average error for first model is equal to average error for the second model. So we say that model 1 is as good as model 2. Okay, do you agree with this? Do you agree with this statement that says both the models are equally good? Do you agree with this or not? If you look at the error values, okay, so what impression does the error values give? When you look at the error values for both the models, what is your impression on the performance of the models? Whether second model is good or the first model is good, or as per the calculations we made just now, both are same. So what is your conclusion? You please respond.
Both are same.
Cheppandi, someone is saying.
Both are same, sir.
So someone has answered this according to the formula average error cost function, because the cost function value for both the models is same. His conclusion is both models are performance is same. What about others? What about the opinion of others? First model is better or second model is better or both are same?
Both are same, sir.
Both are same. Okay. Okay. Almost all of you might be under the impression that both models performance is same, because the cost function value is same for both the cases. You are under that impression. Okay. That is the drawback of this cost function. That is the drawback of this cost function average error. In fact, both the models performance is different. Okay. To find out the difference between both the models, let us use different. Let us look at different cost functions. Okay. The first loss function that is very easy to understand is bias error. Bias error or mean bias error. So whatever we have calculated till now, whatever error that we have calculated till now is what is known as mean bias error. ఇందాక మనం మాట్లాడుకున్నది ఏంటండి? So what is this quantity? What is this quantity? difference between the actual value for the ith example minus the predicted value for the ith example. Actually, there should be I here. Okay. Predicted value for the ith example. So another name for this is what is known as error or loss. Another name for this is bias. Another name for this is bias. Okay. So you are adding all the bias values and you are dividing that by total number of observations 1 by n. So this cost function is known as mean bias error. Mean bias error. ఇక్కడ in this example whatever we have calculated here is called mean bias. So the mean bias for the first case is 0 and the mean bias for the second example is 0. Because their mean bias values are same, we are claiming that both the models performance is same. Bias, and the spelling for this is BIAS, mean bias error. Why it is known as mean bias? Because the other name for error is bias and this is the mean value of the bias, so it is known as mean bias error. The problem here is the problem here is the error can be sometimes positive and sometimes negative. So when you add these errors, there may be possibility that the net value is 0 because the positive value and the negative value you are adding, considering the signs, it may happen that the net value or the net sum is 0. Okay. When do you say the error is positive? Looking at this, when do you say for this case is it positive or negative? What is this quantity? What is this error? Is it positive or negative? This is positive. What about this case? What about this case? E case and so what is this value? This is 1, 2, 3, 4, 5, 6. For the case of sixth example, for the case of sixth example, this is the actual value y6, and what is this quantity? Predicted value for the sixth example. So what is the difference between the actual and predicted value? Is that positive or negative? This is negative error. So this is negative error. So those examples that lie below the line, okay, those examples will give the negative errors. So this example will give negative. Whereas for these cases, the actual value is more than the predicted value. So this is a predicted value for this case. So the actual value is greater than predicted value. Means assume that there is one person in your class with height say h15, okay, and you have asked the regression algorithm, given his height, what will be his weight. So the regression algorithm has predicted his weight like this. This is y15 cap. But in fact, his actual weight is more than the predicted value given by the regression algorithm. So because his actual weight is more than the predicted value, we say the error is positive for this case. So like that, the error can be positive or negative. So when you add all these values, when you add all these errors, it may happen that these errors will cancel each other and the net sum is 0. That is the reason why you cannot distinguish these two models, because these two models gives rise to zero mean bias error. Okay. So how do you overcome this? That when you add positive and negative values, there may be possibility of getting net value or net sum 0. So how do you overcome that? Don't consider the sign of the error, whether it is positive or negative, error is error. Okay. So how to get the absolute value, how to get the magnitude without considering the direction or sign? If you take absolute quantity, you will get the magnitude. If you apply absolute function, we get the magnitude without considering the sign. Okay. So that is the only difference between the previous formula and the current formula, this formula. What is the name? The name is mean absolute error. Mean absolute error, because you have calculated. So this is error for ith sample. Because you have calculated the absolute value, we are saying that it is mean absolute error. It is also called as L1 loss. This absolute value is also called as L1 loss. Okay. What is the problem with this mean absolute error function? It is very difficult to calculate the slope of these error functions. Gradient is the other name for slope. So if you take this function 1 by n sigma I is equal to n, 1 to n, absolute value of yi minus yi cap. See here yi should be there, yi cap. It will be difficult to calculate the gradient value of this function. I told you at the beginning that whatever cost function that we take, its derivative, it should be easy to calculate the derivative. If it is difficult to calculate the derivative, we don't consider such cost functions. Okay. So that is a drawback of this mean absolute error cost function. And this is more robust to outliers, because because of the outlier because of the outliers, this error function will not be affected much. Okay. Robust means because of the presence of outliers, this error function will not be affected. So in our case, what is a mean absolute error for the first model? Mean absolute error for the first model. You have to take the absolute values of the errors. So 1, 2, 3, 4, 4 divided by 4, 4 divided by 4, which
One,
is
sir.
1. Whereas for the second model, what is the mean absolute error?
1, sir.
1 ఎట్లా అవుతుంది? Absolute value of minus 10. 10. So 10, 20, 30, 40. 40 divided by
Sorry,
4.
sir. 4, 10, sir. 10, sir.
So absolute value of all the errors, add that divided by number of examples. So 10. Now what is your conclusion? First model has mean absolute error 1 and the second model has mean absolute error 10. So what is your conclusion? We vote for the first model in this case. Okay. So when you consider mean bias error, we say that the first model is equal to the second model. Whereas when we consider the mean absolute error, for this case the mean bias error for the first model is 0 and for the second model also it is 0. Whereas in this case mean absolute error for the first model,
1,
mean
sir.
absolute error is
1.
1 and for the second model mean absolute error is
10.
40 by 4, that is 10.
10.
So it is 10. So your conclusion is which one is better? Model 1 performance is greater than model 2. అంతే కదా, whichever regression algorithm gives you minimum error, that algorithm you prefer. Okay. But what is the problem with this cost function? Computing the derivatives is difficult. So that is the reason why we don't go for mean absolute error cost functions. This is more familiar to you. What is another way to uh, nullify the effect of sign? మైనస్ కి నెగిటివ్, మైనస్ కి ప్లస్ కి డిఫరెన్స్ లేకుండా చేయాలి అని అంటే వాట్ ఈస్ ద అదర్ వే? ఫస్ట్ వే ఈజ్ టు క్యాలిక్యులేట్ ద అబ్సల్యూట్ వాల్యూ. ద అదర్ వే ఈజ్ టు రైజ్ ద వాల్యూ టు ద పవర్ 2. సో ఇఫ్ యూ స్క్వేర్ ద వాల్యూ, then the sign, influence of sign can be nullified. Okay. So if you square minus 1, you will get 1. If you square plus 1, you will get 1. Okay. So that is the reason why instead of taking the absolute value in this formula, we take what we take? Error for the ith example whole square. Okay. Error for the ith example whole square. So what is the name given to this? Mean square error. Mean square error. Because you are calculating the error and you are raising the error to the power 2. You are calculating the square of the error and you are dividing that by number of observations. So in fact you are calculating mean square error. It is also known as quadratic loss function, because it is a quadratic term to the power 2 kada, quadratic term, it is known as quadratic loss. It's also known as L2 loss. So these are the names you come across when you calculate, when you assess the performance of a machine learning algorithms. So L2 loss or quadratic loss or mean square error, all are same. So the mathematical expression for that is this one. Now, what is the mean square error for the first model? For the first model, what is the mean square error?
1, sir.
Oh, good. Minus 1 whole square plus, so all ones. Okay. So, because you already know about it, let us straight away calculate that value. So, for the first model, sum of the squares of the error is 4 divided by 4. So, this is 1. Now, what about mean square error for the second model?
100, sir.
Minus 10 square. If you remember the data that we have considered.
100, sir.
So 100, when you square this 100, 100, 100. So when you add all these things, 400 divided by 4. So as he mentioned, the mean square error for the second model is 100. So what is your conclusion when you consider this cost function, mean square error cost function? What is your conclusion? Model
Is
1 is
is
better
great.
than, model 1 performance is better than second model performance. So same information we obtain when we use mean absolute error. But the problem with mean absolute error is calculating the derivative of the function is difficult, which is required for optimization purpose. So because of that reason, we have gone for this. But the problem with this is because you are squaring the error, because you are calculating the error raised to the power 2, it is more influenced by outliers. This is heavily influenced by outliers. So whenever your data has outliers, never use this cost function. Okay. And what is the advantage?
Sir, outlays means.
Okay, I will come to you. What is the advantage? It is easy to calculate the gradients, or it is easy to find derivative of this function. Tell me, what's your doubt?
Sir, outlays means, sir.
అవుట్లయర్ అంటే ఇందా చెప్పాను కదా, ఎక్స్ట్రీమ్ వాల్యూస్ ఇన్ ద డేటా సెట్. ఫర్ ఎగ్జాంపుల్, if I take the mid marks of all students in your class, okay, there are some students who secured more than 95%, and there are some students who secure single digit, and rest of the students, their marks are between say 50 to 70. Rest of the student marks are between 50 to 70, and very few students secure more than 95, and very few students secure single digits. So those whose performance is either very high or very low, they are called extreme cases or outliers. They are called outliers. Did you understand what is meant by an outlier?
Yes, sir. Yes, sir.
Oh, obviously, what solution you give, because you are calculating the square, you are saying that it is more influenced by outlier. So how to overcome that? This is a solution. Because you are calculating the square of the error, it is, this term is more influenced by outlier. So how to overcome the influence of outlier? Because you are squaring the error, to overcome that or to compensate that, you have to take the square root. You have to take the square root. So another cost function is root mean square error. So if you do that, what will be the first model performance or mean error?
One,
Mean
sir.
root mean square error? 1.
One.
Second model root mean square
10.
error?
10.
10. Still you claim that the first model is better than the second one. Okay. Now there are some cost functions which will calculate the relative error. Relative error. So relative error, how do you calculate relative error? How do you calculate? Say 100 cases weight ఉన్న 100 cases actual weight ఉన్న స్టూడెంట్ 100 cases actual weight ఉన్న స్టూడెంట్కి ప్రిడిక్టెడ్ వాల్యూ 80 cases అండి. ప్రిడిక్టెడ్ వాల్యూ 80 cases. In our case, the error for this, so error for this example EI is ఎంతండి 20 cases. అంతే కదా, యాక్చువల్ మైనస్ ప్రిడిక్టెడ్. సో దిస్ ఈజ్ actual and this is predicted, and the difference between these two is 20 cases. If I want to calculate the relative error instead of absolute error, if I want to calculate the relative error, what I should do? 20 cases is the error for a person whose actual weight is 100 kgs. So you look at this term in the denominator, what we are using? This is error. We all know that this is the error for the ith example. So error for the ith example is divided by actual value of the ith example. Why we are doing 100 cases actual weight ఉన్న వ్యక్తికి relative error? What is this relative error? What is this relative error? ఎంత వచ్చిందండి? 0.2 is the relative error. In other words, we say the relative error is 20%. We say the relative error is 20%. So whenever you want to calculate error as a percentage of actual value, we use these formulas. This is the error as a percentage of this actual value. And 20% of the actual weight is the error. అంతే కదా, his actual weight is 100 whereas the predicted value is 80, so the error is 20%. Positive side or negative side? The error is 20% towards positive or negative? Actual minus predicted. So what kind of error is this? Positive error or negative error?
Positive, sir.
ఏంటండి?
Positive,
Positive error.
sir.
Okay. Okay, positive error. So this is the cost function that we use sometimes, especially when we want to calculate the error as a percentage of the actual value. Of course, ఇక్కడ డ్రాబ్యాక్ ఉందండి. ఫస్ట్ మీన్ బయాస్ ఎర్రర్లో ఉన్న డ్రాబ్యాక్ ఇక్కడ ఉంది. ఏంటి? పాజిటివ్ ఎర్రరు, నెగిటివ్ ఎర్రరు, పాజిటివ్ పాజిటివ్ ఎర్రరు, నెగిటివ్ ఎర్రరు రెండు కలిస్తే క్యాన్సిల్ అయిపోయి జీరో వచ్చే ఛాన్స్ ఉంది. సో ఆ ప్రాబ్లమ్ని ఓవర్కమ్ చేయడానికి సైన్ని మనం తీసేసేయాలి, ఓన్లీ మ్యాగ్నిట్యూడ్ కన్సిడర్ చేయాలి. సో మ్యాగ్నిట్యూడ్ కన్సిడర్ చేయాలి అని అంటే ఏం చేయాలి? We have to apply the absolute function to the numerator. You have to apply the absolute value to the numerator. So if you apply this mean percentage error, in our case, what will be the error? So you do this later on at home. You calculate the mean percentage error for both the models and also calculate the mean absolute percentage error for both the models and find out which one is better if you use this cost function. Okay. Okay, this is about the cost functions that we use in case of regression. Okay. Suppose if we go for classification, if we use classification algorithms, then we use these formulas: hinge loss or multi-class SVM loss. So the name here is hinge loss or multi-class SVM loss. Okay. See, in this case, we have three training examples. This is the first example, this is the second example, and this one is the third example. Okay. And what is the output space? Our algorithm has to classify whether the given input is a dog, cat, or a horse. So the output space y is equal to, so the target label, class label, can be either this or this or this. What we should do is we will give the image, we will give one image to the algorithm, and it has to classify whether the image has a dog, whether it is the image of a dog or cat or horse. Three class classification problem. Three class classification problem. Okay. How do we calculate hinge loss? Hinge loss is calculated with this formula. Look at the formula to calculate the hinge loss. So maximum value of 0, comma. So hinge loss is given by max value of either the first term or the second term. Okay, and sigma of all these things. What is this j not equals to yi? J not equals to yi. Suppose if the actual class label, let us assume that this is the first example, I is equal to 1, I is equal to 2, I is equal to 3, and this is a predicted values. J is equal to dog, J is equal to, so for dog, what is a, see, in case of first example, you have given the image of a dog, you have given the image of a dog, and the classifier has given these probabilities or these values. The classifier has given these values as the outputs. For the first case, it is minus 0.39, okay, minus 0.39, and for the second case, minus 4.61, and the third case, it is 1.03. These are not probabilities. It has given some outputs, okay. You have given the actual images of dog, okay. For dog class it has given this output, for cat class it has given this output, and for the horse class it has given this output, okay. How do you calculate the hinge loss? Okay. So j not equals to yi, j not equals to yi. So let us take one example here. First training example. This is the first training example. Okay. Max of 0, 0. First training example belongs to which class? The first training example is an image of a dog. So will you consider this value where j is equal to I? Will you consider this value? No.
Sir,
ఇక్కడ ఏమని ఇచ్చారండి? j
minus.
not equals to yi. For the first training example, what is the class label? What is the class label? Y1. What is the class label? Dog. For the second training example, what is the class label? Cat. And the third training example class label is horse. So ఇక్కడ ఏమన్నారు? What is the formula? J not equals to yi. So for the first training example, because the actual class label is a dog, you should not consider this term. Consider other terms, okay. So sj minus syi plus 1. What is this sj and syi? Here s means score, s means score. So for the first training example, our classifier has given this much score to this class label. Dog ki ఈ స్కోర్ ఎంత అండి? minus 0.39. For the second class label, it has given this much score, minus 4.61. And this is the score. This is the score for the third class label. Score of j minus score of yi plus 1. Score of j minus score of yi plus 1. Where j is not equals to yi. Because the first training example belongs to dog, you should not take this for first training example. You should not take this term. ఇంకా రిమైనింగ్ టర్మ్స్ ఏంటి? ఇవి స్కోర్ ఆఫ్ j minus 4. example 1.49 okay. Okay, he is considering this as I and this as J, no problem. So this is the output or the classifier when you show the classifier the image of a dog. So this is the input. He is considering these images as inputs. And these are the outputs given by the classifier when you show the image of a dog. And when you show the image of a cat, these are the outputs given by the classifier. And when you show the image of a horse, these are the outputs given by the classifier. So when you show the image of a horse, the classifier has given this much score to the class label dog, this much score to the class label cat, and this much score to the class label horse. Okay, these are not probabilities, these are scores. Okay, so for the first case, j not equals to I, you have consider I is equal to 1 initially. For the first training example, I is equal to 1. Okay, this is the first training example. So for I is equal to 1, you should not consider j which is equals to 1. So ఇది consider j. So score of j into 1.49 minus score of I 0.39 plus 1. If you look at this formula, score of j minus score of yi plus 1, because we have in the first training example we have given the dog as input, we should not consider this value. This is score of yi, this is the score of y1, score of y1. So 1.49 minus of minus 0.39 plus 1. Similarly 4.21 minus of minus 0.39 plus 1. So this is one term, max of 0 comma 4.21 minus of, for the first class label dog case ki ఏంటండి score 0.39. So 0.39 plus 1. So what is the max of these two terms? This is max of 0 comma 2.88, this is max comma 0.56. So దీంట్లో maximum 2.88, దీంట్లో maximum 5.6. Okay, so if you add these two, we will get 8.48. Okay, so ఇక్కడ చూడండి, when you show the dog as input, these are the scores given by the classifier. Okay, so the loss is very high loss as very wrong prediction. Okay, similarly for the second training example, you have given cat as the second training example. So ఈ వాల్యూ తీసేసేయాలి. ఈ వాల్యూ ఏమవుతుంది, స్కోర్ ఆఫ్ y2. సో దీంట్లో నుంచి తీసేసేయాలి మిగతావి. సో సెకండ్ ట్రైనింగ్ ఎగ్జాంపుల్ minus 4.61 minus of score of yi 3.28 plus 1. Similarly ఇంకొక టర్మ్ 1.46 minus of 3.28 plus 1. So if you do that, you will get 0 plus 0, and the loss is 0 for the second example. Why it is 0? Why it has given 0 hinge loss for the second example? When you show the cat, your classifier has given highest score to which class label? When you show the cat image, your classifier has given highest score to which class label? Cat. That is the reason why your hinge loss is 0. Whereas in the first case, when you show the classifier the image of a dog, it has given highest score to which class label? Horse, which is a blunder. So that is the reason why for the first example, it has given very high hinge loss. Similarly, for the third case, when you show the image of a horse, it has given highest score to which one? Dog. So obviously the loss should be high for this case. So for the third case, you should consider this as score of yi, because ఇక్కడ I ఏంటండి? హార్స్. క్లాస్ లెవెల్ ఏంటి? హార్స్. సో స్కోర్ ఆఫ్ హార్స్. S of yi is minus 2.27. సో ఇప్పుడు మీరు ఈ ఫార్ములా తీసుకోండి. మ్యాక్స్ ఆఫ్ 0, j 1.03 minus of 2.27 plus 1. Similarly, you calculate this term. So max of 0, 4.3 plus max of 0, 0.9. So if you add these two, you will get a high hinge loss. Why there is a high hinge loss? Because you have shown the image of a horse and the classifier has given highest score to which class label? Dog. So that is why the hinge loss is more in this case. So when you add the hinge losses for all the examples, we have considered only 3 examples. Like that, if you add hinge losses for all the examples, you get the total hinge loss. And if you divide that by total number of examples, you will get mean hinge loss. Okay. I will stop here. Tomorrow I will continue further. Any doubts that you would like to ask? I advise you to go through the videos that are uploaded. Okay. If you are not able to follow the video, you can refer to the notes. It's very easy to follow the video because it contains explanation as well instead of static content. Venkateswara, shall I stop the meeting?
ఓకే సార్. సార్
Ah,
సార్ మీన్ స్క్వేర్ వాల్యూ చెప్పారు కదా సార్, ఒకసారి అక్కడికి వెళ్ళండి.
yes. Do you want me to show that?
ఎస్ సార్. అంటే సార్ అక్కడ ఒక ఎగ్జాంపుల్ చెప్పారు కదా సార్.
Mean square error, yes.
Yes sir, 80 is the predicted value for the student out of 100 marks అన్నారు కదా సార్. సార్ నాకు అక్కడ ఇంకొక ఎగ్జాంపుల్ యాడ్ చేయాలనిపిస్తుంది సార్. సార్ ఇప్పుడు మన ఫింగర్ ప్రింట్ స్కానర్స్ ఉన్నాయి కదా సార్.
Yes.
సార్ ఫింగర్ ప్రింట్ స్కానర్స్ లో 80% ఇస్ ద ప్రిడిక్టెడ్ వాల్యూ ఫర్ ది ఫింగర్ ప్రింట్ స్కానర్ సార్. 80% కనుక మ్యాచ్ అయితే మ్యాచింగ్ సక్సెస్ఫుల్ గా వస్తుంది, లేకపోతే ఎర్రర్ వస్తుంది సార్.
Okay. Are you talking about outliers?
No, sir. No, sir. I got clarity about outliers, sir. But I adding one more example on. Yes, sir.
Okay. You are saying that if the match is 80%, if there is a match of 80%, then it accepts your fingerprint.
Yes, sir.
Okay,
So,
good. చెప్పండి.
predictive value for fingerprint is 80%, sir. I want to say that.
You are talking about percentage error.
Yes, sir.
You are saying if the percentage error is less than 20, you accept that as a correct fingerprint.
Yes, sir.
You are talking about percentages. When you talk about percentage error, you have to consider these two, last two. This one, mean percentage error and mean absolute percentage error. Of all the loss functions, this is very good. Mean absolute percentage error.
Yes.
But again, what is the problem if you take absolute value? If you take absolute value, what is the problem? Here I have highlighted. Computing the gradients is difficult. So which loss function do you suggest of all these, which will overcome all these things? Root mean square error. Root mean square error. If you raise the error to the power 2, you can overcome the sign values. Positive, negative cancel out అనేది overcome చేయొచ్చు. Because when you raise the error to the power 2, అవుట్లయర్స్ బాగా ఇన్ఫ్లుయెన్స్ చేస్తాయి. దాని ఎఫెక్ట్ని నలిఫై చేయడానికి వీఆర్ టేకింగ్ ద స్క్వేర్ రూట్. అండ్ ద థర్డ్ అడ్వాంటేజ్ ఈస్ డెరివేటివ్స్ కెన్ బి క్యాలిక్యులేటెడ్ ఈజీలీ. సో దిస్ హ్యాస్ all the advantages. That is the reason why for several applications we always go for root mean square error. You might have heard about this for in several cases. This is not the first time that you are hearing about this error function. ఇప్పటికే చాలాసార్లు వినుంటారు. Because it has so many advantages, we always go for root mean square error. Okay. Any doubt? Otherwise I will stop here.